Good morning, students. So in our last class, we complete two questions from the exercise 13.2. Is not it? That first one and the second one. So today here we discuss the question number 3. And if you see the question number 3 is here, a metal pipe is 77 centimeter long. The inner diameter of a cross section is 4 centimeter. So let's see here, inner diameter is given as well as the outer diameter being 4.4 centimeter. Isn't it? And here what you have to find out, we have to find out inner curved surface area as well as outer curved surface area as well as the total surface area we have to find out. So in this case, when a pipe given to us here, which one is we consider as a right circular cylinder, and in this case what happened, the inner diameter and the outer diameter given to us. So in this case, if you see the diagram properly here, suppose this one is the pipe. You see, this one is the pipe here, and in this case, in this pipe, if you see, this inner part is the inner diameter we consider, as well as this one is the outer diameter. So in this case, one thing you remember here, if we consider this one at the top one, if we consider this one is look like as a circle, this one is the inner diameter as well as this one is the outer diameter. So the inner diameter is given here 4 centimeter as well as the outer diameter. If we consider this one is the center, the outer diameter is given how much? 4.4 centimeter. These two are given. So this one is the diagram here. This one is the inner part as well as this one is the outside or outer part. So here, if the inner diameter is 4 centimeter and the outer is 4.4 centimeter. So here easily we can find out the radius because the diameter given, so easily we can find out the radius. So in this case, the height is given. Height equals to how much? The height is given 77 centimeter. The height is this one. So in this case, three results are we have to find out: inner curved surface area, outer curved surface area, as well as the total curved surface area we have to find out here. First of all, when you have to find out the inner one, so that's why in case of inner one we have to consider the inner diameter. This part we have to consider, and in this case when you have to consider the inner diameter, so from there the inner diameter is 4, so with the help of this one easily we can find out the curved surface area of the inner part, isn't it? This one is the thickness here, this one is the thickness of this pipe, and the thickness of this pipe, if you find out here 4.4 and 4, that means the thickness is how much? 0.4 centimeter. So in this case, inner curved surface area first you have to find out, then next you have to find out the outer, and then finally you have to find out the total surface area. Total surface area formula, all of you know what you have to do. We have to just close the outer part at the top and the bottom with the help of two circles, and then this one is the total surface area. So one by one we have to find out here. So first one we have to find out inner curved surface area. So in case of inner curved surface area equals to here, if we consider the, in this case, if we consider the radius for the inner part, if we consider the radius is R1, clear? And for the outer part, if we consider the radius is R2, because here two radius we need, so that's why separately you have to consider. So diameter is given here actually, and the formula we have to write here, this one is 2 pi r1h. So this one is the curved surface area formula, and in this case here the diameter if we consider by d1, diameter for the inner part, the diameter is given 4 centimeter, and for this one here the radius is how much? Obviously 4 by 2, the half of this, so this one we have to write 2 centimeter. So for the first one, inner curved surface area, the radius is 2 centimeter, and if we put this value here, 2 into pi means how much? 22 by 7 into radius we get here 2 into height is how much? 77. So if we calculate this one, this 7 cancel with 7, 11, and then ultimately 2 into 22 into 2. So this one we get here 968 centimeter square. Is it clear? So this one is here, the answer is how much? 968 centimeter square. So this one is the inner curved surface area, that means this inner part. So next one we need the outer one. So outer diameter is how much? So here this one is not radius, this one is diameter actually, and this diameter we have to convert into radius. So that means this one is actually diameter. So now in this case, what you have to do for the second one, if you write down the outer curved surface area, so outer curved surface area. So in this case, we have to write down the formula is 2 pi r2h. So in this case, the diameter is given how much? If we consider the diameter is d2, and this one we have to write 4.4 centimeter, and therefore here the radius how much we get? Half of this one, so 4.4 divided by 2. Ultimately this one we get here 2.2 centimeter. Is it clear? So if we put this value here, this one we get here 2 into 22 by 7 into this one is 2.2 into height is 77. Again we have to multiply this 2 here. You see, again we have to multiply this 7, cancel with 77, and ultimately if we calculate this result, and here we get 1064.8 centimeter square. This one is the outer curved surface area of this right circular cylinder or the pipe. And the third one, finally we have to find out the total surface area. So for total surface area, one thing you see here, for total surface area, here we have to consider this circle. We need the area of this circle, as well as here we need the area of this circle. But one thing here you see, very important point here, because when we have to take the circle, when we have to close these two parts, the top and the bottom, because here two curved surface areas are there. One is the inner one, another one is outer one. So when you have to consider for both circle, when you have to consider the top and the bottom as closed, so that means this smaller part common for both cylinder. For inner, this one is closed, as well as for outer. Again this one here we get two circles are we get here, two areas are we get. You see here this smaller one, for this smaller one, for example for this smaller one we get one circle here, this one, and for the next one, for the bigger one, again if you see here another circle here we get like in this way. So when you have to close both the results, that means total surface area of the smaller one as well as the total surface area of the bigger one. So when you have to consider the top and bottom as closed, that means this part, this region is common for both, for the smaller one as well as for the bigger one. This smaller portion is common for both the diagrams. That means this part come two times, so we have to subtract one time. Here this part come two times for the smaller one as well as for the bigger one. For two times this one is come, so that's why we have to consider only one time. So that's why we have to subtract this part one time. Is it clear? For example, one more example, if you see, suppose this one is a circle and we have to close this one. Suppose this one is the closed part here. Again here we have to consider another circle, bigger one, and here we have to close this part like in this way. So now in this case you see this part is two times come or not? So one time we have to subtract here. This one is the main reason. So now for that reason what you have to do, we have to just consider the curved surface area of the bigger one plus curved surface area of the smaller one, and the top and the bottom part we have to close by two circle. So the bigger circle area is what? Pi. The radius we consider r2, so that's why here pi r2 square. So this type of how many circles are there? Two circles. So that's why we have to write 2 pi r2 square. As well as the smaller one is the radius we consider r1, so that's why 2 pi r1 square, two times. So from the bigger one we have to subtract the smaller one, because this region is come two times and we have to consider only one time. So that's why from the bigger one we have to subtract the smaller one. So that's why here when you have to write down the total surface area, in this case we have to write here 2 pi r1h plus the second one we write 2 pi r2h, and then the area of the bigger one two times we get, so that's why we write here 2 pi r2 square minus 2 pi r1 square. All of you understood this one? Why we write 2 pi r2 square? Because one area is this one, another one is this one. So if we add these two times of pi r2 square, because the bigger one we consider the radius is r2, and for the smaller one r1, so that's why 2 times of pi r1 square, and this part is common for both smaller the bigger part, so that's why we have to subtract this smaller part from the bigger part, and then we get the total surface area here. So now in this case 2 pi r1h, already we know this value is how much? 968. So in place of this one we have to write 968. r2h, that means this value also we know, and this one we write here 1064.8, and then here what we have to do, if we calculate this one, let's see here, 2 pi is common, and then here we write r2 square minus this one we write here r1 square, so this one we write here r1 square. So if we calculate this one, the whole result, so r2 square, so this one is we have to write 968 plus of this one is 1064.8 plus of 2 into pi means 22 by 7, and r2 means the radius is how much? 2.2, so that's why we write 2.2 whole square, isn't it? Minus of r1 means what? 2, so that's why we have to write this one is 2 square, and we have to calculate this one. And finally when we calculate this one, then the final answer here we get 2038.08, and if you calculate this one, 2038.08 centimeter square, because the unit is given here centimeter square, 2038.08 centimeter square. So the calculation is yours, you have to calculate this result and just check out whether this one is 2038.08 or not. So this one is the required answer. So in this question mainly 3 parts are here: inner curved surface area, outer curved surface area, as well as the total surface area we have to find out. And this question is very important question examination point of view. So I hope all of you understood this question properly. So in our next class we continue this exercise and start from question number 4.